All right, guys, let's do Chapter 2, Section 2.3 outline. We've got multiplication, division of whole numbers. Multiplication can be seen as repeated addition. Or when we multiply things, what exactly are we doing? We're joining a number of equivalent sets. So that just means we're doing like 2 plus 2 plus 2 plus 2 is 8, or we could say 2 times 4, 1, 2, 3, and 4 equals 8. Same thing. It's like we're either repeating addition or it's multiplication. How can you demonstrate multiplication using models? As joining equivalent sets and as joining segments of equal length on a number line. All right, so we have area model. The two numbers being multiplied represent the dimensions of a rectangle / rows and columns. So she has this example 2 inches by 2 inches. So you have 2 rows by 2 columns, which she has labeled over here. So if you count each space in between, it's 1, 2, 3, and 4. So that would be like 2 times 2 equals 4. I did it a little bit more of a visual so you could see it in bigger circumstances. So I did 4 by 6. Like, so if you had 4 by 6 or 6 by 4, you get 24. But we could see that as saying you have a row 4 that way, and a column 6 that way. So that would give you 24 total. So you have all of these, you count each one individually and down till you get to the 24. So it's like a visual way of showing the 4 by 6. Okay, so on this A, we have 2.5 times 3.25. We're going to use the lattice approach to solve this. So what we need to do first is we're going to create or change the fractions into decimals. So 2.5 is the same thing as 2.5 times 3.25. So in order to do this easily, we're going to make us a little square or rectangle, and we have to draw blocks for each what do you call it? Each number in the number. So we have like 2.5 would go here, and then we have 3.25 would go here. So then with the lattice approach, we create divisions between these, and we start multiplying just like regular. So 5 times 3, we have 15. 3 times 2, we have the 3 times 2 is 6. And then we have 2 times 5 is 10. 2 times 2, we have 4, so we have 0, 4. 5 times 2 is 10. And 5 times 5 is 25. So what we need to do now is add through. So we have 5, and then these would be 2. All of this would be 5, 6, 7, 8, 9, 10, 11. So you got the 1, and you carry the other one. So you have 2 plus 6 is 8, and 0. So that gives us 8.125. So if we multiply it out, it gives us the same thing. Like if we want to do like 2.25 and we want to like do improper fractions, we would do 2 times 2 plus 1. So it would be 4 plus 1 is 5. 5 over 2 times 3 times 4 is 12 plus 1 is 13. That would give us 13 over 2. And that's going to be multiply straight across. So or 5 times 13 is 65, and 2 times, wait, 2 times 4, I don't know what I'm doing. It's late. 2 times 4 is 8, so that would give us 8 and an eighth, which is the same thing as saying 8.125. So it checks out. All right. We're going to work on the lattice approach, which is kind of cool. What it is it's an approach, is an alternative to long multiplication. So instead of having to write it out and do all these different steps, it's kind of like a fast way that helps you keep organized and stay on track. So I just created the problem 25 times 44. So for each digit you have and each number being multiplied, it would be a square. So say this one has 25 has 2 digits and a 44 has 2 digits. So that would give you like a 4 cube. So you start off with like the 25 and then the 44. And then you divide each one of those squares in half this way. And then we start multiplying. So you would first start with the 4 times 5 and it'd be 20. So you put the tens digit up there and the ones down here. And then 4 times 2 is 8. So there's no 10, so you would have 8 in the ones. And then 4 times 2, we have 8. And then, oh, sorry. We're doing 4 times 5 first. 4 times 5 is 20. And then 4 times 2 is 8. So then what we do is you're going to follow each row. So each row is going to have its own color so we can kind of visually see it. So if we followed like the purple row, you'd be adding all these in the row. So 0 plus 0 is 0. And then here we have 8 plus 2 is 10. And then 8 plus 2, again, oops. Sorry, my bad. All right, so just like when we normally add, we have to carry over. So 8 plus 2 is 10. So the 0 would go here, and we'd carry the 1 to the next column. So then you have 2 plus 1 is 3, plus 8 is 11. So you'd have the 1 down here, and then you would carry the 1. So then 1 plus 0 is 1. So our answer would start from over here and work our way around. So our answer is 1100. So you have 1, 1, 1, 1, 0, 0. So 25 times 44 is 1100. And it works because it's highly organized and it's easy to keep track of your results. All right, let's try another one that she gave us. So we have 3 times 4. We're going to start here. 3 times 4 is 12. 3 times 3 is 9. So you have 0 there. And 3 times 2 is 6. You have 0 and 6. And 4 times 4 is 16. And 4 times 3 is 12. And then 4 times 2 is 8. Then we have 5 times 4 is 20. And 5 times 3 is 15. And 5 times 2 is 10. So now we're going to follow those lines down and we're going to add. So I find it easier to do it this way. So you have 0 here, and then you have 6 plus 2 plus 5. So that's 13. You carry that 1, and then you have 2, 3, 4, 5, 6, 7. And And then down here you have 9, 10, 11, 12, that's 20. So add 2. So 2 plus 6 is 8. And then you have 0. So we're going to start here, go all the way around. So that would give us the 80730. So that'd be 80,730. And then we have number 5. It says multiplication as repeated addition. It's kind of like what I said earlier. So it's 6 times 4. Oh, no, I did that wrong. It's 6 times 4 is going to be equal to 6 plus 6 plus 6 plus 6. Or 2 by 3 is the same thing as saying 2 plus 2 plus 2. So you get 6 either way. Sorry, these are supposed to be addition, not multiplication. And it says multiplication using different bases. Okay, so we've got 32 to the 5th base 5, 32 base 5 times 32 base 5. So what we need to do is convert the base 5 numbers to base 10 so we can multiply them. So in order to do that, we need to multiply each place value by the power or the value of that column. So 5 to the 0 and 5 to the 1 because we're doing it by 5 because we're on base 5. So that would be 5 to the 0 power is 1. So 1 times 2 is 2. 5 to the 1 power is 5 times 3 is 15. So 15 plus 2 equals 17. Now because both of these are the same number, it's just 17 by 17. And 17 times 17 is 289. Now this is base 10. So to find the answer, we have to reduce it back to base 5. So we're going to find the values of the places. So we have, why do we always do that? 5 to the first is 5. 5 to the second is equal to 25. It's 125 for 3. And then we have 625. Now we know 625 is too big, so we know our answer is going to have 3 place values. So we need to start with the largest place value, and we're going to divide 125 divided by 289, and that goes 2 times, that's 250. Gives us a remainder of 39. So we have 2 remainder of 39. So we need to get this to 0, so we need to keep dividing for the next place values. So we do 39 divided by, and we're going to go over here to the next value of 25. 25 divided by 39, so we have 25, and then we have 14, so we have 1 remainder 14. So we still have a remainder, so we're going to divide that out by the next place value is 5, so 5 into 14 is 2. 2 times 5 is 10. The remainder of 4. Still have a remainder, so we need to reduce it to the last place value. So you have 1 divided by 4 is 4, with a remainder of 0. So our answer is going to be 2,124 base 5. Okay, so let's try the next one. We got 23. Now these are 2 different numbers, so it'll be a little bit different. So we're going to say we need to multiply by the value of the place value. So that would be the 4s because we're changing it to 10. So 4 to the first power is 1. 1 times 3 is 3. And we're going to add 4 times 2 is 8. So 8 plus 3 is 11. And then 4, so we have 1 times 2 is 2, plus 4 is going to be equal to 6. So we're multiplying 11 by 6, base 10. It's going to give us 66. So now we need to go back to base 4. So what we need to do is find the different values. So we have 4 is equal to 1. 4, 1 is equal to 4. 4, 2 is equal to 16. 4, 3, let's see, 64. Okay, so we know we shouldn't go any higher than that. So we have 64. We're going to divide that by the 66. So we have 66, oops, 64 divided by 66 gives us 1, remainder of 2. So that would be 1 remainder 2. Got to get that to 0, so we have to divide it out by the next place value, the 16. So 16 divided by 2 is 0. It won't go in evenly. So we still have a remainder of 2. So we're going to divide it again. And this time we're at the 4 place value. Still can't do it. A remainder of 2. Take that 2. Now we're going to divide it by the 1. So 1 divided by 2 is 2. Remainder 0. So that means our answer is 1002. 1002 base 4. So 23 base 4 times 12 base 4 is equal to 1002 base 4. Okay. Next, A says, example, if you have sets or M sets with N objects in each set, the total number of objects is M times N. B, M and N are the factors and M times N is the product. The Cartesian product of two sets A and B is the set of all ordered pairs X and Y such that X is an element of A and Y is an element of B. Now we've got A. Division may be modeled by separating a set of objects into equivalent subsets. Ask yourself, how many objects are in each subset? Example, given a total of 60 cans and 5 cases, how many cans are in each case? So if you divide 60 by 5, you get 12. B, and the division of whole numbers, A and B, where B is not equal to 0, A divided by B equals C, if and only if C is a unique whole number such that C times B equals A in the equation. Now this equation, I think she left out on accident because this is like word for word what's in the book. So I'm going off of this equation here for the answers. So A is the dividend. So this first number is the dividend. B is the divisor. It's what's being divided. And C is the quotient. It's the answer. Division. Now, all of the zero stuff I am not sure about. So I'm going to let you work on it. And we'll go over it later because I'm really not sure. The closure property. I have the product of two whole numbers is always a whole number. So that means like if you have 2 times 3, it's 6. You're not going to, if you have 2 full whole numbers, you're not going to get anything other than a whole number. Same as like 4 times 8, you're going to get a whole number 32. You're not going to get a negative number, or you're not going to get like a fraction. Identity property. Anything multiplied by 1 gives us the number itself. So you have like 45 times 1, you give us 45. 25 times 1, you get 25. That one's pretty easy. All right, so then you have the commutative property. And I was reading it, I saw a video that says, think you're moving it. So like you're rearranging it. The moving the factor still creates the same answer. So if you have 3 times 5 is 15. If you do 5 times 3, it's still 15. So I just drew a picture that kind of represents, it doesn't matter which way you look at it, it's still going to equal the same value. All right, so then we have the associative property. It says think group. So it doesn't matter which way you group an equation, it's still going to even the same result. Because like if you take 2 times 3 times 2 is going to be equal to like the 6 times 2. Or if you take, which is 12, or if you take 2 times 2, then times 3, that's going to be 4 times 3, which is still equal to 12. So it doesn't matter which way you group it, it all kind of works the same. It's all the same answer. And the picture, it just shows the volume, and each, depending on, it doesn't matter which way you lay it, it's still going to have the same volume. All right, so we have zero property. It says a times 0 equals 0 times a equals 0. Like 0 times a equals 0, and a times 0 equals 0. So 8 times 0 equals 0, and 0 times 8 equals 0. So it just says if you anything you multiply by 0, you're going to get 0. Then we have distributive property of multiplication over addition. It says for whole numbers a, b, c, a times b plus c is equal to a times b plus a times c. So what it's saying, like, if you multiply this section and then you add this section, it's the same as if you just multiply it all out together. Number 8, it says, what is the relationship between multiplication and division? Division is the inverse of multiplication. In division, we separate even groups, and in multiplication, we join 2 equal groups. So I just wrote like a divided by 4 is equal to 2, and then 4 times 4 equals 8. So it's either you're like either putting them together or you're splitting them apart. And I think down here is she's just giving us an example of the distributive property, I'm assuming. I don't know if there's actually a problem in this, but I think it's just a distributive property example. Yeah, like I said, I really don't understand the 0, why it's either infinite or it's, what is the other word? Infinite or, yeah. So I'm going to look over it some more, see if I can figure it out. But right now, that's what I got for this one. I do want to go by and show you that I messed up on a lot of those other videos about the sequence. So if we have sequence that is, let's say 4 plus 4, 4 plus 4 is 12, 16, and 20. Like this is our sequence. And we're adding 4 each time. This would be, what is it, arithmetic? Sorry, I can't. So So we're doing arithmetic, which means you're adding to get from one term to the other. So if we're trying to find the nth term, we would say, like if n is 1, our first term is going to equal 4. So that would say 4, because we're adding, is 4 plus 0. N is 2, our second term is going to be 8. So that would be 8 is equal to 4, our starting term, plus our difference of 4. Our third term equals 12. So we have 12 is equal to 4, starting term, plus 4, which is our difference. And then n equals 4. Fourth term is equal to 16. 16 is equal to 4 plus 4 plus 4 plus 4. So in order to find the nth term, which is where I was wrong before, our nth term is going to be equal to our starting number, our 4, plus n, plus 4, which is our difference, times n minus 1. So it's not to the power, it's just times. So let's say if we want to find that the fifth term, this 20, like double check our work, we would say like the fifth term is going to be equal to 4 plus 4. So 4 is our starting number, and the other 4 is our difference. And multiply that by 5 minus 1, because we're finding that fifth term. So that 5 comes from here. So that would give us 4 plus 4 times 4. So that would be 4 plus 16, which is going to be equal to 20. So 20 and 20. So I'm sorry if I messed up before. So it's not 4 to the n minus 1. It's 4 times n minus 1 when you're doing the arithmetic sequence. If you have any questions, please call or text or message or whatever. I will try to help. Again, thanks for the patience.